What's up everybody, welcome back to the Engineer channel. My name is Tim, the engineer, and today I've got a bunch of cool updates and a great project for you all. The number one biggest update on my training is that I finally did it. After a lot of years of trying, I broke into the sub 6 minute mile, which is great progress because only a few years ago I was running in the 8s and then the 7s, and then I finally broke into the 6s and I was super proud of that. But just the other day, I actually ran 1 mile in 5 minutes and 51 seconds, which is, absolutely huge for me. So that's just great progress on the way to being in the 4s, hopefully, is as far as I'll get naturally, and then the world record standing at around 3 minutes and 43 seconds. So hopefully we'll beat that with some of the augmentation tech that we're building, which brings us to today's project. Now you might remember in a previous video, I built kind of like a budget Mars gravity simulator. And one of the major issues that I had with it was that using the harness that I planned to use for some of my other designs, basically I couldn't walk or run while part of my mass was being suspended. And I knew from that moment I needed to create a better human-machine interface, basically the beginning of my Iron Man suit. And in order for me to do that, I actually needed a completely fresh and new design, and that's where it leads us today. But I started looking at other kinds of applications that use this sort of like human-machine interface technology, and I found a good one. So let me show you what I came up with. So the next human-machine interface will be based on a military issue Molly 2 rucksack frame. And so what a rucksack is basically like a reinforced frame that mounts over your shoulders like a backpack, but a rucksack can carry all kinds of attachments and like really huge cargo holding capacity. So this had the whole rucksack actually on it when I bought it. I should have probably filmed that, but I took it off. And what we're left with is this really nicely designed back plate, which is sort of molded to the contours of your back and has a lot of carrying capacity and attachment points, which is going to be really, really helpful for the build. And the reason why I'm using something like this rather than designing it myself is this was a government program that could probably cost, tens of millions of dollars to design this backplate. So rather than me trying to reinvent the wheel and do something myself, I can lean on all this great engineering, and that's going to help me go faster on this project, figuratively speaking. So the only problem with the rucksack frame is it's meant to actually carry loads in the downward direction, right? There'd be things on your back that you're basically carrying with you. But the difference between that and the drone pack or the E-RUNR is that when you're using those devices, actually forces are pushing in the upward direction, which isn't gonna work well for this design. So we're gonna need to modify it. I have a design that I think is gonna be pretty sweet, so let me show you that now. I did my best to visualize what I have in my head, and I'm not CAD modeling the entire design because this backplate would take forever to CAD model, and it's not gonna add a whole lot of value to the project. So what you're looking at here is the backplate from a side view, and then these are the shoulder straps that go over my shoulders, and there's the lap band. And so what was happening on the previous harness is that I was actually trying to hold up the force through my legs, which restricted my leg movement, whereas rather on this one, don't mind my finger mark there, I'm actually gonna attach a piece of aluminum bar to the back plate in 2 locations, which is going to give me a rigid mounting point, where I'm going to actually use a torsion spring. That's a spring that creates, sort of rotational energy, stores rotational energy to drive a bicycle seat, or in this case, a 3D printed custom seat, sort of up into my tailbone area. So that way the forces that are pulling upward of my body will be basically input into a place that's not my legs. And I'm not sure yet, depending upon the strength of the torsion spring I end up with, whether or not I'm gonna need to run another line back up to the waist belt, but that's basically it. It's taking this whole orange assembly and some custom 3D printed parts and mounting it onto that Molly 2 rucksack frame. And really, the design might change as the video goes, but we won't know unless we build it, so let's hop to it. So I got this off-the-shelf bike seat that I was hoping I'd be able to use when I got in some other parts. Don't worry about that. That'll be in a future video. But the problem is that this front here is too long for me to run with, and I was going to try and remove it, but I'm a little worried those sharp edges are gonna be uncomfortable. So I'm actually gonna do my best to replicate the seat, which I thought would be something really cool to show on the channel, because if you look from the side, you can get a 2D profile. And if you look from the top, you can also get a 2D profile. And with those together, we can actually make three-dimensional splines that will help me design and ultimately 3D print this part, but a little custom for our application. But in order to do that, we need to take some really nice high-resolution photos. That's where this light box comes in. So no great place to put it, unfortunately, but set this light box up and it's got a really nice white backdrop. So what I'll be able to do is set this in and actually take squared off photos from the top and from the sides. And then that's gonna help me get really nice definition for when I move these photos into my CAD program. I started by importing the two images that we took in the photo booth into SolidWorks, so that way I could actually get some reference geometry and be able to use these curves as reference points. I then made a bounding box that was to let me know basically how large I wanted the seat generally to be, and this was partially constrained by the size of my 3D printer. I then made a series of planes and sketches which matched the seat's geometry. So you can see here from a side view, I was actually grabbing onto the seat's geometry, and then also from a top view, doing the same, but modified to be more narrow so that I'll be able to run with it. And then I created what's called a projected curve. So that way I could use all of this geometry together to make a boundary. Now this is surface modeling, which means that this isn't like a solid object. You can imagine this almost to be like an infinitely thin, like a single layer of atoms that are making up this curvature, which is how you make organic shapes that aren't like squares, rectangles, circles. These would be, things that are more analogous to like bones, which don't have any sort of like shapes you could call out. So the computer is doing a lot of the solving for the geometry. Now I'm oversimplifying how difficult this was because it's actually pretty challenging. But if I turn off the sketches here, we're left with this single surface, which I can then start to work with a bit more, create a lower level because I'm eventually going to turn this into a solid, and then actually mirror it over to the other side. And that's the very beginning of our seat. Working through some of the other features that I did here, did things like solidified, added cuts and curvatures to the back, made a cut opening for the actual rail that's going to support the seat, and then sort of like a relief here so it wouldn't be so pointy under my tailbone. And then from there, all I had left to do was generate some mounting holes. And because I'm going to put this in my 3D printer, I actually had to create a flat surface so that way I could stand this up in the 3D printer and give it a way that it could be printed. And those are just some of the limitations of a 3D printer. Like you can't print things flat sideways without supports, and then those supports make things kind of nasty. But this seat is now ready for the 3D printer. Let's go put it on, see how it comes out. I've had this MakerBot 3D printer for about 12 years now. And you don't have to use it all the time, but when you need it, it's like the most handy tool in the world because I can take an idea like this and have a part in my hands later on that day. The rest of the brackets that I made for the back plate were much simpler, but I thought they were just so satisfying the way they snapped into place, and they made locating the bar on the back plate super easy. Just need to drill some holes and mount them up. Taking a quick break from the build because this video is actually a lot harder to film than I thought it was going to be. It turns out that so much of designing this interface is subjective. It's really just about how it feels in my body, that I spent a lot of time in front of a mirror just trying different things, different configurations, tying to different parts of my body, and it was not entertaining at all. But I did end up with 3 very distinct designs, so I'm going to walk you through those now. The very first was the straight bar design, which just uses a 90-degree bracket and bolts a completely straight bar all the way up my back. No fancy mechanisms, just a bar. I like this design for its simplicity, but it was majorly flawed in that, I could never feel like I got the seat underneath me and it would fall out from the seated position really easily if I bent over at all. It just never felt like it was actually staying in the place that I wanted it to, so that one's not going to work. The second design that I tried utilized a really nice pivot joint, and it looked promising, even had a torsion spring in place to keep the joint continuously closing and keep the seat underneath me. But once again, this design was pretty lackluster. It turned out that the torsion spring didn't generate enough torque to truly keep the seat underneath me when I would try and pull up on the device or simulate any kind of real movement, bending over, etc. It wouldn't reseat the seat back underneath me, so this wasn't going to work either. It turned out that my original intuition was correct, that we were going to need straps, so I removed the torsion spring from my hinge joint, attached some nylon straps underneath with nice grommets, tied them into the railing, and then used some tri-glides for adjustment and some hooks to clip onto the other parts of the harness. This design definitely worked the best of everything I tried. It felt secure, but like it wasn't impeding my movement. And I definitely would like to make some adjustments to how the pivot works, sort of with the articulation of my spine, but we've got lots of other work to do, so we'll call this good for today and improve it later down the road. That's going to do it for today's video. I hope you really liked getting some insight into the design process, and things are just going to start accelerating from here, no pun intended. I've got the frame for the E-RUNR here in the background. I've got the electric motors. The full, basically rolling frame is ready to be put together. We're going to do that in the next video. So please like this video, subscribe to the channel, make sure your notifications are on, maybe tell a friend about what we're up to. And this is really where things are going to start getting interesting. Until next time, onward and upward, and I'm out.
I grew up in a place where they told you what to chase, told you how to run the race. Every move was on the page, but I didn't like their way. Had to fight and misbehave, had to find a way to change, had to leave to find my way. Caught up in a daydream, I beat my mind up.